This is the chemical reactions part of the test review for Unit 12. So first thing we're going to do is 1 through 6. We're going to make sure that we balance these equations and then identify the type of reaction. So in part 1, I have an A on each side, I have a B on each side, I have a C on each side. My coefficients would be 1 all the way across, and it's balanced. When we're looking at this, we're looking for patterns. I have a compound and a single element, and on this side I have a single element, a different single element, and a new compound. So this particular pattern is called single replacement. Sometimes they'll use displacement instead of the word replacement, but that both of those would be considered correct because I have one single thing replacing something else in the equation, and on this side I have a new single thing. Looking at reaction number 2, first we're going to start by balancing it, and it just so happens that I have an iron on each side, I have a copper on each side, and a sulfate on each side, so it's another easy to balance ones across the board. And it follows that same iron's the single thing. On this side of the equation, iron has a partner and copper's by itself. So that is also single replacement. In number 3, I have silver nitrate, magnesium chloride, silver chloride, and magnesium nitrate. So everything on both sides of these are all compounds, and we refer to this as a double replacement, or you could use the word displacement, that's acceptable too. I'm going to put a star by this one. We're going to come back to this one when we talk about things later, because this one's unique. Let's balance that. I have a silver on each side. I have 1 nitrate on this side. Over here I have 2 nitrates. So if I put a coefficient of 2 here, then that changes my silver. So now I've got 2 silvers, 2 nitrates, 1 magnesium on each side, and I have 2 chlorines on each side, so these coefficients will be 1, and that's balanced. In equation number 4, this is the one we told you guys to make sure you pay attention to. When I have a carbohydrate and oxygen, that means something is going to burn, and so my products are carbon dioxide and water. Anytime my products are carbon dioxide and water, this is that unique type that we call combustion. Okay, key thing you're looking for there is your products being carbon dioxide and water. And let's make sure that this one is balanced also. There's 8 hydrogens, so if I put a 4 here. Alright, so if I put a coefficient of 4 here, that gives me 8 hydrogens, so my hydrogens are balanced. If I put a coefficient of 3 here, that gives me 3 carbons, and so my carbons are balanced. So I have on this side a total of 3 times 2 is 6 oxygens, plus another 4, right? 4 times 1 is 4, so that's a total of 10. So I need a coefficient of 5 in front of my oxygen and a coefficient of 1 there. So that's balanced. Okay, looking at reaction number 5, let's balance this one first. So in order for it to be balanced, when I don't have even numbers here, we're going to multiply oxygen by 3 to give us a total of 6. Here we're going to multiply this by 2, and so then I need a coefficient of 2, and now I'm balanced. This one thing is breaking apart, or we call this decomposition. So when one thing breaks into more than one thing, its decomposition. All right, and then my next one, we have, again, that uneven number. I've got 3 oxygens here and 2 there. So we're going to put a coefficient of 2 to make that 2 times 3 is 6. This gets a coefficient of 3. 3 times 2 is 6 oxygens. 2 times 2 is 4. So I get a coefficient of 4 irons. And then when I have 2 things coming together to make one thing, that is synthesis. And number 4, this is just like the lab we did when we first introduced this. You're going to draw the representation of number 6. So number 6 says we've got 4 irons, and so they're individual irons. There's 1, 2, 3, 4 irons, plus this tells me I have 3 O2s. The subscript 2 lets me know that those oxygens are together, and I'm going to have 3 of them. So there's my 3 O2s, and then in my product, oh, here's our arrow over here, my product is going to be 2 Fe2s, so here's Fe2O3. This is all connecting. So there's one Fe2O3, and then I need my second Fe2O3. And so I have drawn a representation of number 6 in this particle diagram below. 8 says define oxidation and reduction reactions. In a redox reaction, one ion gains electrons while another loses electrons. So looking at the ones up here, remember we put this star beside double replacement? Double replacement's the only reaction where nothing is oxidized, nothing is reduced. If you look at all of the other examples, in each one of them you've got something that at some point is 0 and has no charge, and on the other side it has a different charge. So the second part of 8, example 1, 2, 4, 5, and 6 are considered redox reactions. The only one that is not a redox reaction is the precipitation reaction, which is number 3. So in class, we kind of broke up types of reactions into 3 different types. We had redox reactions, we had precipitation reactions, and the third type we had was acid-base, which we said we would learn about later. Well, under precipitation, there's only one type of precipitation, and that type is double replacement. And under redox, this is where we have the most types of reactions. We had single replacement, we had combustion, we also had synthesis, and decomposition. So all 4 of those fall in the redox group, and only double replacement falls in the precipitation category. So number 9, a student added some lead nitrate solution to a beaker with potassium iodide. the solution and yellow solid was formed. What could be concluded from this reaction? This is what you guys actually did in lab. And so this key yellow solid thing and the fact that lead nitrate is a compound and potassium iodide is a compound should be a clue that a precipitation reaction took place. And that yellow solid, that was your precipitate that was formed. Equations are balanced so that chemical reactions follow the law of conservation of mass. This means the number of moles of reactants is going to be the same as the number of moles of products. So in the above, we already talked about this, our precipitate reaction is reaction number 3 because it's our only double replacement reaction.